Hey everyone, welcome back to the channel. Today, we're tackling a fun project, building a great calculator using Python's Tkinter library. Let's explore why graphical user interfaces matter. With a command line interface, you type commands and get text-based responses functional but not very user-friendly. For example, if we want to calculate a student's final grade based on their scores, we manually input numbers and wait for the response for next prompt, which can be tedious and prone to errors. Now, imagine the same program with a GUI. Instead of typing, you click buttons and see results instantly. It's intuitive, visually appealing, and easy to use, making your program feel like a professional application. That's the power of a GUI. It turns basic functionality into an engaging and accessible experience. That's where Tkinter comes in. Tkinter allows us to build a graphical user interface, or GUI, so our code is not only functional but also user-friendly and visually pleasant to work with. Today, we'll build a great calculator that takes input for attendance in class activities, homework, midterm, and final exams, then calculates the final grade using weighted averages. This project is perfect for beginners who want to learn how to create user-friendly Python applications. We will use Replit for Python scripting because Replit is an easily available online editor that lets you code, run, and share projects directly from your browser. Secondly, there is no installation required for Replit. It also supports various programming languages and offers real-time collaboration and instant feedback. It is perfect for quick development and testing of applications like our great calculator. Comment below if you want a video on Replit account setup. First, we are importing the Tkinter library, which is used to create graphical user interfaces in Python. The tk alias allows us to reference Tkinter functions more conveniently throughout the code. We are also importing the MessageBox module from Tkinter. MessageBox provides a way to show pop-up messages, which we will use to display error messages if the user inputs invalid data. Next, we define a new function called calculateGrade. This function will handle the logic for calculating the final grade based on the inputs provided by the user. The try block begins a section of code that attempts to execute some statements. If an error occurs during this execution, Python will look for an except block to handle the error. These lines retrieve the input values entered by the user in the graphical user interface fields for attendance, in-class activities, homework, midterm, and final exam. The get method fetches the string value from each entry field, and float method converts it to a floating point number so that it can be used in calculations. This if statement ensures if each input value is between 0 and 100. If any value falls outside this range, the code raises a value error exception with a message indicating that scores must be between 0 and 100. This line calculates the final grade by applying specific weightings to each input score. Attendance and in-class activities are each weighted at 10%, homework and midterm at 25%, and the final exam at 30%. We will then update the grade label on the graphical user interface to display the calculated final grade. The config method changes the text of the label to show the grade, formatted to 2 decimal places as indicated by .2f in this command. If a value error occurs, this except block is triggered. It shows an error message using a pop-up window informing the user to input valid numbers. We also need a clear function that can clear all the values of attendance, midterm, homework, and final exam from the previous session. Therefore, let's define another function called clearFields. This function will be used to reset all input fields, allowing the user to start fresh without having to close and reopen the application. These lines clear the content of each entry field in graphical user interface by deleting all text from the start to the end. 0 indicates the start of the text in respective field, and tk.n means last index of the text. Additionally, the grade label is reset to its default text, which is final grade. Now comes the real graphical user interface program. These code lines create the main application window by initializing a Tkinter instance called root. The title method sets the window title to grade calculator. A touch of light blue for the background makes the interface visually pleasant. The code hash F0F8FF represents color code of light blue. One can follow this chart to find the colors of their own choice. This is a very important command for graphical user interface. Let's go through the contents of this command one by one. We create a label here with the text attendance. Background color represented by BG is assigned a color code. Similarly, FG represents the text color, which is set to black. The grid command sets the position of the label at 0th row and 0th column, with horizontal and vertical padding represented by pad X and pad Y respectively. These parameters can be changed to alter the position of the label. Next, we create the input field for attendance. We set its background color to white using the BG argument. Moreover, the grid elements are adjusted to fit for the window. Let's take a look at what did we accomplish with the code until now. Look, we have the label for the attendance and a text field now for user to fill in the value of attendance ranging from 0 to 100. Since we notice a good padding on both horizontal and vertical sides, we can continue with other labels and text fields for in-class activities, homework, midterms, and final grade. Notice that we are going to follow same color guide, but with each new label and text field, we increase the number of rows, but the columns remain consistent. Moreover, the padding on the horizontal and vertical axis also remains consistent. Let's take a look now with new labels and text fields. It is noticeable that all the labels and text fields are consistent, and we can continue now with the placing of buttons to notify program that we have entered the values and now do the calculations. For this purpose, we will place a button with text calculate grade. The Tkinter command for button is similar to label, as it takes a text, background color, text color, and grid parameters. One additional command is given with the function to execute when user presses the button. We are using the function calculate grade for this button. Similarly, we will add a button to clear all fields and use the clear fields function to execute when user presses this button. Finally, we create the label to display the final grade. Here we set BG to a light beige color and use font to style the text in bold Arial size 12. Root main loop makes the graphical user interface responsive and interactive, entering the value of each field one by one. Look, we can see the final grade calculated easily by an interactive and user-friendly graphical user interface in Python. It is noticeable that a value error window is shown as midterm value can only be between 0 and 100. Also, this graphical user interface is able to clear all the fields by one click. We can simply click on the clear button to clear all the fields. Thus, today we have gone through the basics of Tkinter library in Python to develop a simple graphical user interface. For more interesting tutorials like this, please like, comment, and subscribe. Your feedback is key to our improvement.